have a new chapter. We're studying tectonic plates and earthquakes. And this is the
David
and Herman 7th grade science show. So we're talking about earthquakes and volcanoes. And
No.
no?
No,
You
I don't like
that?
earthquakes at all.
All right, so you've been playing at this. Oh, can you see it? Okay, we've been playing at this map, right? It's a USGS map, so it's accurate data, good data. If you'll notice closely, you should have figured it out by now that this red line is the famous San Andreas Fault Zone. But if you'll notice past San Bernardino, it seems to disappear. And so when they put that line there, we didn't have satellites, we didn't have computers, and many people, geologists, say they missed the mark. They should have put the line right through here. So you don't have oceans to study, you don't have mountains, and we have mountains, but forests to study, but you do have the most active earthquake fault in the world. It's right here. It's called the San Jacinto Fault Zone, for obvious reasons, and it runs from the Gulf of California up to San Bernardino, and then it starts right there. So if you notice, look at the data. The data shows under your backyard, this whole thing is going to slide out. It's going to do it every year that far. It's been going on for 200 million years, maybe 250 million years, and it's going to continue. So don't sell the farm. As this breaks away, this ocean will work its way up. But the question is, was the San Andreas Fault put in the wrong place? And it really should be going through your backyard. In San Jacinto, Hemet, down to Glamis. Okay? So we're going to do a little demonstration in sand, and Dave's going to show you the sand, and we'll cut to the demonstration.
Okay.
All right. All right, so Dave is playing with some kinetic sand. It's not magic sand, it's not magnetic. I found this in Michael's. That's like $60 worth right there. So Dave's going to pick it up, parts of it, and watch how it changes its shape back.
This is
Isn't that
really
cool?
This is really cool, and it doesn't leave any grains on your hand.
It doesn't. Metropolitan Water District has some of this that they let you play with at your museum, the Water Museum, down in Hemet. And Eastern Municipal has some in their little schoolhouse over on Sanderson. So we're going to watch a demonstration using this sand to show why we have mountains, relatively small mountains, around San Jacinto, Hemet, on the way down to the Gulf of California.
Wow. This is cool.
Okay, ready? Okay, today's lab is explaining why we have mountains near San Jacinto Valley, all the way down to Glamis into San Diego. This is kinetic sand. This side of the plate is the Pacific tectonic plate. It includes Hawaii, Los Angeles, San Diego. This side of the plate is the North American plate. It includes Barstow, Banning, Las Vegas, and most of the continental in Mexico is on this plate. It's moving south and east slowly. You're on this side, Pacific plate, moving north and west pretty quickly, pretty fast, about 1 inch to 2 inches a year. So let's go back in time. 20 million years ago, the ocean has receded. It used to be at Barstow. Now the ocean is down south of us. And we're going to go back from 20, maybe 15 million years ago to present. Watch what happens when this tectonic plate, which is a transform boundary, moves. So if I can move it, come on, let's go. There we go. So this is like 15 million years ago, 14 million years ago, 13 million years ago, 12 million years ago, 10 million years ago, 8 million years ago. Do you notice what's happening along what we now call the San Jacinto Fault Zone? You see the mountains? Zoom in for the mountains. This is like 5 million years ago. Notice that it forms small mountains, not the big things like the Himalayas or the Andes or the Rocky Mountains or the Appalachians, but there's small mountains all around us. And it's caused because of the friction of the two plates dislodging the dirt and making small mountains anywhere. This is evidence, number one, that the main split is not over at the old San Andreas fault zone, south of San Bernardino, but it really is under your feet, under your house, under your backyard in San Jacinto and Glamis, all the way down to Mexico. And so we go down. This is today. Notice the mountains. Zoom in on the mountains. Zoom back. And this is today. The mountains we have are from these two transform boundaries moving past each other. You guys got it? Okay. Into the future. If we continue to go, the Pacific plate continues to move out into the ocean an inch a year, maybe 2 inches a year, and pretty soon San Diego is going to be up where Los Angeles is now, and Los Angeles is going to be up where San Francisco is now, and we're all going to head off towards Alaska and Japan as we go. You guys get the idea?
Yeah.
Okay. Cut.